Hello all, welcome back to my channel. Today we will be discussing the chapter Work, Energy and Power. So, first we'll be discussing what is work. Work is said to be done when a force applied on a body displaces the body to a certain distance in the direction of applied force. It is measured by the product of the force and the distance moved in the direction of the force. Thus, W equals F minus S. If an object undergoes a displacement S along a straight line while acted on a force that makes an angle theta with S as shown, the work done W by the agent is the product of the component of force in the direction of displacement and the magnitude of displacement. If we plot a graph between force applied and the displacement, then work done can be obtained by finding the area under the Fs graph. If a spring is stretched or compressed by a small distance from its unstretched configuration, the spring will exert a force on the block given by F equals minus kx, where x is compression or elongation in spring, k is a constant called spring constant whose value depends inversely on unstretched length, and the nature of material of spring. The negative sign indicates that the direction of the spring force is opposite to x, the displacement of the free end. What is energy? The energy of a body is its capacity to do work. Anything which is able to do work is said to possess energy. Energy is measured in the same unit as that of work, namely joule. Mechanical energy is of two types: kinetic energy and potential energy. Kinetic energy. The energy possessed by a body by virtue of its motion is known as its kinetic energy. For an object of mass m and having a velocity v, the kinetic energy is given by k E or k equals half mv square. Potential energy. The energy possessed by a body by virtue of its position or condition is known as its potential energy. There are two common forms of potential energy: gravitational and elastic. Gravitational potential energy of a body is the energy possessed by the body by virtue of its position above the surface of the earth. It is given by potential energy equals mgh, where m is the mass of the body, g acceleration due to gravity on the surface of earth, h height through which the body is raised. When an elastic body is displaced from its equilibrium position, work is needed to be done against a restoring elastic force. The work done is stored up in the body in the form of its elastic potential energy. If an elastic spring is stretched by a distance y from its equilibrium position, then its elastic potential energy is given by U equals half kx square, where k is the force constant of given spring. Now, in this slide, we will be discussing what is work energy theorem. According to work energy theorem, the work done by a force on a body is equal to the change in kinetic energy of the body. The law of conservation of energy will be discussed in this slide. According to the law of conservation of energy, the total energy of an isolated system does not change. Energy may be transformed from one form to another, but the total energy of an isolated system remains constant. Energy can neither be created nor destroyed. Besides mechanical energy, the energy may manifest itself in many other forms. Some of these forms are thermal energy, electrical energy, chemical energy, visual light energy, nuclear energy, etc. Equivalence of mass and energy. According to Einstein, mass and energy are interconvertible. That is, mass can be converted into energy and energy can be converted into mass. Collision. Collision is defined as an isolated event in which two or more colliding bodies exert relatively strong forces on each other for a relatively short time. Collision between particles have been divided broadly into two types: elastic collisions, inelastic collisions. Elastic collision. A collision between two particles or bodies is said to be elastic if both the linear momentum and the kinetic energy of the system remain conserved. Example: collision between atomic particles, atoms, marble balls and billiard balls. Inelastic collision. A collision is said to be inelastic if the linear momentum of the energy remains conserved, but its kinetic energy is not conserved. Example: when we drop a ball of wet putty onto the floor, then the collision between the ball and floor is an inelastic collision. Collision is said to be one-dimensional if the colliding particles move along the same straight line path both before as well as after the collision. In one-dimensional elastic collision, the relative velocity of approach before collision is equal to the relative velocity of separation after collision. Coefficient of restitution or coefficient of resilience. Coefficient of restitution is defined as the ratio of relative velocity of separation after collision to the relative velocity of approach before collision. Non-conservative forces. A force is said to be non-conservative if the work done in moving from one point to another depends upon the path followed. Let W be the work done in moving from A to B following the path 1, W2 through the path 2 and W3 through the path 3. Examples of non-conservative forces are forces of friction, viscous force. Law of conservation of energy holds good for both conservative and non-conservative forces. A force is said to be conservative if the work done by or against force is dependent only on the initial and the final position of the body and not on the path followed by the body. A force is said to be non-conservative if the work done by or against a force is dependent on the path followed by the body. Work done by the conservative force in a closed path is zero. Work done by the non-conservative force in a closed path is not zero. Examples of conservative forces are gravitational force, magnetic force, electrostatic force. Examples of non-conservative forces are friction, viscous force, induction force in cyclotron, etc. So that's all for this video. Thank you all.